Okay, so the second derivative rule basically states if f double prime of x is equal to 0, then there is an inflection point there. If f double prime of x is greater than 0, then the function will be concave up. If f double prime of x is less than 0, then the function will be concave down as such. Now, concave up means that there will be a relative min, while concave down means that there will be a relative maximum, wherever that is right there. Okay, so not every of the ones that you get here will be inflection points. Let's see. You could do this on a function f of x, like f x is equal to what's the fourth plus 3x squared plus 1. Okay, so f double prime of x is equal to 12x squared plus 6. And when f double prime of x is equal to 0, 12x squared plus 6, then that'd be negative 6 equals x squared equal to negative, which means that there are no inflection points, which means that there are no concavity changes. Okay, so that was a pretty crappy example. Okay, so let's pick another example then. Let's do f of x is equal to x cubed plus 3x squared plus 1. Okay, so f double prime of x is equal to 6x plus 6. Alright, so x is equal to negative 1. That would be where the inflection point of that function right here is. To find if each side is concave up or down, you take numbers on either side of this, like negative 2 and 0, and test them in f double prime of x. So you plug this in and you get a negative number, and you plug this in and you get a positive number. Okay, so since it's negative right here, that means it is concave down, and this is concave up. Sorry, not good with the camera. Okay, so that means it looks something like that, or like that, whatever. So that means there will be relative mins right here and relative maxes over there. You can apply this to the first derivative rule, because once you find your critical points, using the second derivative rule, you can find out, for example, like whether it's a relative min or a relative max. For example, let's take this function, take the first derivative of that. Whoopsies, shadow. Equal to, let me readjust my hand real quick. Okay, much better. It's equal to x, or 3x squared plus 6x plus 4. And let's set that equal to 0. Oops, didn't pick a very good example, so you could just do quadratic formula. Negative 6 plus or minus square root of 36 minus b4 times 4 times 3 over whatever, because it doesn't really matter, because this turns out irrational, so it's never equal to 0, so thus has no critical points, and it just becomes something without a critical point. So you don't really need to find out whether there's a relative min or relative max. But if, for example, you did need to do that for some oddball reason, for example, okay, new example, sorry about that. F prime of x is equal to 3x squared minus 6x plus 4. Okay, in this case there will be a 6 plus minus 36. Shit. Okay, never mind. Okay, well you get the point, okay? Because I suck at making examples and yeah, I'm kind of in a rush. So, okay, so that's basically the second derivative rule. And if you know me, then just aim me if you need more help on this, okay? Because I stink at explaining to a camera. Alright, thanks.